Compensating network is basically a network which improves the system performance. The performance of the system is analyzed in time domain with the help of rise time, peak time, settling time, peak overshoot, steady state error, etc. So these parameters are helpful to know the performance of the system. Whether the system is good or bad is judged by these parameters. The same system can be analyzed in frequency domain also, and the parameters that are helpful here are resonant peak, resonant frequency, bandwidth, cutoff rate, gain margin and phase margin. So the same system can be analyzed either in time domain or in frequency domain. These parameters will be helpful whether the system is good or bad. And the time response of the system, it actually consists of transient part and steady state part. So there are some parameters that are helpful to know the system performance in transient period, and there are some parameters which are helpful to know the performance of the system in steady state part. Now, what exactly is the compensating network? For example, if you have a system, it has a open loop transfer function G of S, and it has some output C of S, then some feedback for certain input. So this system performance can be seen either this way or in frequency domain. Now I want to modify the performance of the system. Say for example, the peak overshoot is having little higher in the original system. So I want to reduce the peak overshoot. Similarly, the settling time, I would like to reduce the settling time, means improving the speed of response. So I may have to add some network in the system and say it is GC of S. That is nothing but a compensating network. This adding a network to the original system may improve the performance of the system either in transient period or steady state period, or in terms of frequency domain improves the bandwidth, improves the gain margin and phase margin, etc. So the compensating network is nothing but addition of a pole and zero at appropriate location to modify the original system performance. Most of the time gain is the factor we focus to improve the performance of the system. If you increase the gain, there is no doubt the steady state performance of the system will improve, but the stability is a problem. Stability gets affected if you go on increasing the gain. So increasing the gain alone will not be the solution. For that reason, we need to go for compensating network. These compensating networks are classified into lead compensating network, lag compensating network, then lag lead network and lead lag network. Compensating network is classified into 4 categories. So, what is the meaning of lead or lag that is appearing in the term? So, this is basically dealing with sinusoidal frequency response analysis. So, a system, a compensator is excited by a sinusoidal signal, then this compensating network will have an output. It will have an output. That output, phase of this output, if it leads with the phase of the input voltage, then we say it is a lead network. I may have some parameters in this box, and using those components in the box in appropriate fashion, then the output will have, the phase of the output will have leading with the phase of the input voltage, then it is called as lead network. If the output, the phase of the output lags with phase of the input voltage, or input signal, then it is said to be a lag network. So, lead or lag that appears in frequency domain, meaning of that is that compensating network is excited by sinusoidal input, and then lead or lag in the phase angle of the output differentiate the networks. However, the lead network or lag network, it will add pole and zero, at appropriate location, to modify the original system performance. So, lead network also add pole and zero to the system, lag network also adds pole and zero to the system.